Okay, so here we have to solve this logarithmic equation. Log base 8 of x plus log base 8 of x minus 63 is equal to 2. And so the way we're going to do this is we're going to use the law of logarithms, the sum or the product law that says that the sum of two logarithms is the product of their insides. So in other words, I can combine these two into log base 8 of, I'm going to use the square brackets to denote this is everything inside the log of x times x minus 63. And that's, again, still equal to 2. And now you can notice here, this is the definition sort of a log, right? Log base something of something is equal to another number. And so we can actually convert this into exponential form by saying that, right, this is how you convert. Take the base, raise it to the power of the number on the other side, and that's going to equal the part inside. And so we say that 8 squared, or 64, is equal to x squared minus 63. I distributed here, right? X times x is x squared. X times negative 63 is negative 63x. And I'm going to subtract 64 from both sides, right? X squared from both sides. That's going to bring it to the right, because now we just have a quadratic equation. And we can factor this into x minus 64 and x plus 1. And so if we do the equation, we're going to see that x is equal to 64 and x is equal to negative 1. Except the reason I have this box around 64 is that with logarithmic equations, you have to make sure that the solutions you get at the end work with the original domain of the equation. And so here you can see that if I plugged in negative 1 in for x, I'm going to have the log of a negative number. And logarithms are only defined for positive numbers, right? They're not defined for 0 and they're not defined for negative numbers. And so it doesn't work for this one. That would be good enough. But take note that it also doesn't work for this log. Whereas 64, log base 8 of 64, that's defined. And log base 8 of 64 minus 63, that's 1. That's also defined. And so 64 works. And so 64 is our final answer.